A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
Hey everyone, and welcome back to another episode of My Weird Prompts. We are at episode 1066, which is honestly a bit of a milestone when you think about how much the landscape of artificial intelligence has shifted just in the last year or two. I am Corn Poppleberry, and as always, I am joined by my brother and our resident deep diver into all things technical.
Herman Poppleberry here, and I have to say, Corn, I have been looking forward to this specific session all morning. Our housemate Daniel sent over a link to a project he has been working on over on GitHub, and it hits on something that has been a massive thorn in the side of every developer working with autonomous agents lately. It is a project called Agentic AI Architecture Visualization, and it is trying to solve the black box problem, but not in the way most people think.
Right. Because usually when we talk about the black box, we are talking about the neural network itself, the weights and the hidden layers of the model. But what Daniel is pointing out with this project is that there is a second black box that has emerged in the last year, which is the agentic workflow itself. We are moving away from simple chat prompts where you ask a question and get an answer. Now we are building these complex multi-step systems that can browse the web, write code, execute it, and then check their own work. And the problem is, as these systems get more autonomous, they become incredibly hard to follow. You look at the logs, and it is just a mountain of text. It is a total mess of state transitions that no human can reasonably parse in real time.
It is total spaghetti code, but at the logic level rather than the syntax level. If you have ever tried to debug a multi-agent system where one agent delegates a task to a sub-agent, who then calls a tool, which then fails and triggers a recursive correction loop, you know how quickly you lose the thread. Traditional observability tools, things like Langsmith or AirEyes, they do a great job of showing you the traces, the linear sequence of events. But what this project, the Agentic AI Architecture Visualization, is arguing is that a linear trace is actually a lie. It does not represent what the agent is actually doing internally. It is like trying to understand a city by looking at a list of every person who walked down a specific street. You see the movement, but you do not see the infrastructure that guided them there.
That is a really interesting point. Why do you say it is a lie? If the agent does step A, then step B, then step C, isn't a linear timeline the most accurate way to represent that?
In terms of wall clock time, sure, but in terms of the architecture of the thought process, no. Think about how a human solves a complex problem. We do not just walk a straight line, we circle back. We hold multiple conflicting goals in our head at once. We have these latent preferences that guide us, even if we do not explicitly state them. This project is trying to map what it calls the nonlinear and circular workflows. It is moving away from the flowchart and towards something that looks more like a dynamic state map or a graph-based representation of the agent's internal momentum. When you look at a linear log, you are seeing the history. When you look at a state map, you are seeing the potentiality and the constraints.
I love that phrase, internal momentum, because when we look at the prompt Daniel sent over, he specifically mentions two things that this visualization project focuses on: circular loops and latent value spaces. Let's start with the circular loops, because I think that is where most developers are feeling the pain right now. In traditional software, a loop is usually something very clearly defined, like a for loop or a while loop. But in agentic AI, loops are often emergent, right?
Precisely. They are emergent and often unintentional. Think about the REACT pattern, which stands for reason plus act. This has been the standard for agents for a while now. The agent thinks, then it takes an action, then it observes the result, and then it repeats. Now, in a perfect world, that is a spiral moving toward a goal. But in the real world, agents often get stuck in these circular loops where they keep trying the same failed strategy over and over again, but they slightly tweak the wording of their thought process so it looks new to them. They are essentially gaslighting themselves into thinking they are making progress. If you are looking at a linear log, you might not realize you have been in a loop for 10 minutes until you have burned through $5 in compute.
And that is what this visualization project is trying to surface. Instead of just showing a long list of thoughts, it identifies when the agent state is returning to a previous node. It maps those recursive cycles visually. So, as a developer, you can look at the graph and see a big red glowing circle where the agent is just spinning its wheels. It makes the inefficiency visible. It turns a cognitive failure into a geometric shape.
And it goes deeper than just identifying errors. This project is exploring the idea that some circularity is actually a feature, not a bug. We talked about this a bit back in episode 795 when we were looking at sub-agent delegation. Sometimes you want an agent to loop through a self-correction phase before it reports back to the main controller. But you need to be able to see the density of that loop. Is it a tight, efficient loop that is actually improving the output, or is it a loose, wandering loop that is losing the signal in the noise? By visualizing the architecture as a graph rather than a list, you can see the topology of the reasoning. You can see if the agent is actually converging on a solution or just orbiting a problem indefinitely.
Okay, so if the circular loops are about the path the agent takes, then what about the second part of this? The latent value spaces? That sounds a bit more abstract. How does one visualize a latent space in a way that is actually useful for a developer?
This is really the heart of the project. When we talk about latent value spaces in the context of agentic architecture, we are talking about the hidden heuristic preferences that guide an agent's decision-making when it encounters ambiguity. Every time an agent reaches a fork in the road, it makes a choice. Why did it choose tool A over tool B? Usually there is a set of weights or a latent bias in the model that pushes it in one direction. This project tries to map those decision points and visualize the values that were active at that moment. It uses a technique to parse the internal state vectors and project them into a visual field.
So it is almost like looking at a heat map of the agent's priorities.
That is a great way to put it. Imagine a three-dimensional map where the peaks and valleys represent the agent's perceived value of different outcomes. If the agent is task-oriented towards speed, the latent space might be skewed towards certain types of quick and dirty tools. If it is oriented toward accuracy or safety, the space shifts. The visualization project aims to show how these latent values fluctuate during a long-running task. It is fascinating because it allows you to see the agent's gut feeling, for lack of a better term. You can see the tension between competing objectives.
It is interesting you call it a gut feeling, because that connects back to what we discussed in episode 810, the Agentic interview. We were talking about how agents learn to know the user. If an agent has a high latent value for a specific user's preference, that should be visible in the architecture. If the agent is ignoring that preference, the visualization would show a disconnect between the input state and the latent value space. It really moves the conversation from prompt engineering to what Daniel's project calls architecture engineering. We are no longer just shouting instructions at a box. We are designing the internal landscape that the box uses to navigate.
Prompt engineering is like giving someone a set of instructions. Architecture engineering is like building the brain that processes those instructions. And you cannot build a brain if you cannot see how the neurons are firing. One of the technical mechanisms this project uses is parsing the agent's internal logs into a graph-based representation. It is not just looking at the final text output. It is looking at the metadata, the confidence scores, the alternative paths that the agent considered but did not take. It uses a custom parser to extract these state transitions from the JSON-L files that modern agent frameworks like LangGraph or CrewAI output.
Wait, that is a huge point. Visualizing the paths not taken. Most people don't realize that modern agents often generate multiple potential next steps and then use a secondary model or a scoring function to pick one. If you only see the final path, you are missing 90% of the reasoning. You are seeing the winner of an internal debate without hearing the arguments.
Right. You are seeing the tip of the iceberg. This project wants to show you the whole iceberg. It maps the latent value of those discarded paths. If the agent almost chose a path that would have led to a security violation, but then corrected itself at the last millisecond, you want to know that. You want to see that the agent was leaning toward a dangerous latent space. That is a massive insight for AI alignment and safety. It is not just about whether the final answer was safe, it is about whether the reasoning process was robust. If the agent is consistently tempted by high-risk paths, your architecture is brittle, even if the output looks fine today.
I can see how this would be a game changer for debugging. I mean, imagine you are building a smart home agent, something like we talked about in episode 1073. If the agent is trying to decide whether to turn on the sprinklers while you are having a backyard party, there is a conflict of goals there. A linear log might just show the agent deciding not to turn them on, but the visualization might show a huge tension in the latent value space between the irrigation schedule and the presence of humans in the yard. Seeing that tension helps the developer understand if the agent's logic is actually sound or if it just got lucky. It allows us to debug the intent, not just the outcome.
And it also helps with the infinite loop risk. We have all seen agents that get stuck in a recursive loop where they keep trying to access a file that does not exist. In a traditional flowchart, that looks like a single line going back to a previous box. But in this project's visualization, you can see the compute cost and the latency accumulating within that loop. It gives you a physical sense of the weight of the agent's failure. It is like seeing a traffic jam on a map versus just being told that cars are moving slowly. You can see the pressure building up in that specific part of the graph.
So let's talk about the actual implementation of this. If I am a developer and I want to use this Agentic AI architecture visualization tool, how am I actually interacting with it? Is this something that runs alongside my agent in real time?
That is the goal. As of right now, it is primarily a diagnostic tool that you feed your logs into, but the roadmap suggests a move toward real-time observability. You would have a dashboard where you can see the graph expanding as the agent thinks. Each node represents a state, and the edges represent the transitions. The thickness of the edges could represent the latent value or the probability of that transition. And when a loop forms, the graph literally starts to circle back on itself. It is a much more intuitive way to monitor a system that is essentially non-deterministic. You are watching a living organism of logic grow in front of you.
I wonder about the performance overhead of something like this. If you are mapping every single latent value and every discarded thought, doesn't that become a massive data problem in itself? We are already struggling with the sheer volume of telemetry data in modern stacks.
It definitely does. That is one of the trade-offs they are grappling with. You have to decide on the level of fidelity. Do you want to see every single token level decision, or do you want to see higher level conceptual shifts? Most developers will probably want the conceptual level. You want to see when the agent shifts from the research phase to the execution phase. You want to see when it enters a self-correction loop. You don't necessarily need to see every single word it considered. But even at the conceptual level, the amount of data is significant because agents in 26 are running through millions of tokens of context. The project uses a tiered approach where it summarizes low-level transitions into higher-level architectural nodes to keep the visualization readable.
That brings up a good point about the signal-to-noise ratio. We talked about this in episode 810, how as context windows expand, it becomes harder to find the signal. This visualization project is essentially a signal extraction tool. It is taking a mountain of text and turning it into a geometric shape that the human brain can process much faster. We are very good at recognizing patterns in shapes and colors, but we are very bad at recognizing patterns in a 100-page log file. It is about leveraging human spatial intelligence to debug machine intelligence.
It is about cognitive offloading for the developer. If I see a graph that is mostly linear with a few small spirals, I know my agent is behaving well. If I see a tangled mess of overlapping loops and high-tension edges, I know I have an architecture problem. It might mean my prompt is too ambiguous, or it might mean I have given the agent too many conflicting tools. This leads into what we were discussing regarding the second-order effects of this technology. Once you can see the architecture, you start to design agents differently. You start thinking about the topology of the task before you even write the first line of code.
How so? Give me an example of how your design would change once you have this kind of visibility.
Well, instead of just trying to write a better prompt, you might realize that you need to break a single agent into 3 sub-agents because you can see that the latent value space is getting too crowded. It is like realizing that a single person is trying to do too many jobs and their brain is melting. You see the conflict in the visualization, and you say, okay, I need to delegate the research task to a separate agent with its own clean latent space, and then have a supervisor agent manage the transitions. It turns AI development into something much more akin to systems engineering or even urban planning. You are designing the flow of information and the zones of responsibility.
That is a fascinating analogy. Urban planning for the mind of an AI. You are looking at the flow of information, like traffic, and you are trying to prevent bottlenecks and crashes. And if you see a particular intersection where the agent always gets confused, you build a bypass. In this case, the bypass might be a hard-coded logic gate or a more specific tool. You are essentially terraforming the agent's reasoning space to make it more navigable.
Right. And this is why it is so different from traditional tools. Traditional observability is about monitoring. This is about understanding the topology of the reasoning. I think about the project's focus on those circular loops again. In a standard software pipeline, a loop is a very rigid thing. In an agent, a loop is a conversation the agent is having with itself. If you can see that the conversation is becoming repetitive, you can intervene. This project paves the way for what I call human-in-the-loop architectural intervention. It allows us to be active participants in the reasoning process rather than just passive observers of the result.
Wait, explain that. Are you saying we could edit the agent's thought process in real time as we see the graph forming?
That is the dream, isn't it? Imagine the agent is stuck in a loop. You see it on your screen. You click on the node that is causing the problem, and you manually nudge the latent value in a different direction. You basically tell the agent, stop focusing on this specific file and look at this other variable instead. You are not writing a new prompt, you are literally shifting the momentum of the agent's current state. It is like being a navigator for a ship. The agent is the engine and the hull, but you are occasionally nudging the rudder when you see it heading toward a whirlpool. You are providing the high-level heuristic guidance that the model might be lacking in that specific moment.
That would be incredibly powerful. It would make these autonomous systems much more reliable because you have a safety valve that is based on structural understanding, not just a stop command. It also addresses one of the misconceptions people have about agentic AI. Most people think these loops are just errors that we need to eliminate. But as you said, they are often necessary for reasoning. The problem isn't the loop. It is our inability to see inside it. We need to distinguish between a productive cycle and a destructive one.
It is like the difference between a car that is idling and a car that is stuck in the mud. They both look like they aren't moving, but one is a normal state and the other is a failure. Without visualization, you can't tell the difference from the outside. You just see that the agent hasn't given you an answer yet. This project gives you the view under the hood. It shows you if the engine is turning or if the wheels are just spinning in the dirt. It allows for a more nuanced understanding of agentic performance.
I also want to touch on the geopolitical angle here, because we often talk about the US-China AI race. The ability to build reliable, observable agentic systems is going to be a massive competitive advantage. If American companies are building agents that are black boxes, and our competitors are building agents with transparent, observable architectures like what this project is proposing, they are going to be able to iterate much faster. They will have fewer catastrophic failures and more efficient compute usage. Transparency is a productivity multiplier.
That is a great point, Korn. Efficiency is the key word there. In 26, compute is still a scarce and expensive resource. If you can use visualization to identify that your agent is spending 40% of its compute in useless recursive loops, and you can prune those loops, you have just effectively doubled your compute budget. This isn't just a neat tool for developers, it is an optimization framework for the entire AI economy. We need to move away from this brute force approach where we just throw more tokens at a problem and hope the agent figures it out. We need to be surgical. We need to be able to identify the exact moment an agent's reasoning goes off the rails.
And being surgical requires a map. That is what Daniel's project is. It is the map of the agent's internal world. I am curious, Herman, how does this compare to something like traditional SEO, or what we talked about in episode 753, Agentic Behavior Optimization? Back then, we were talking about how to optimize websites so that agents could read them better. Does this visualization help with that too?
It absolutely does. If you are a developer trying to make your data more accessible to AI agents, you can use this tool to see how an agent's latent value space reacts to your content. Does the agent get stuck in a loop when it hits your API? Does its confidence drop when it reads your documentation? You can actually see the agent struggle. Instead of guessing why an agent failed to find information on your site, you can watch the visualization and see exactly where the disconnect happened. It turns the agent into a model user, which is something we touched on in episode 835. You are essentially doing usability testing on the agent's reasoning process.
Right, using agents as model users for UX testing. If you can see the agent's architecture as it navigates your app, you are basically getting a high-resolution brain scan of your user. That is incredibly valuable for design. It takes the guesswork out of the user experience. You can see the friction points in the agent's reasoning, which probably correlate to the friction points a human would feel, just at a much faster scale. It allows us to optimize for both human and machine consumption simultaneously.
And it brings us back to the idea of alignment. If we can see the latent value space, we can ensure that the agent's values are aligned with our own in a way that is verifiable. It is one thing to tell an agent, be ethical. It is another thing to see that the latent value for ethics is consistently high across all decision nodes in the architecture. It moves alignment from a philosophical goal to a technical metric that we can track on a graph. We can literally see the moral compass of the agent as it navigates a complex task.
So, let's get into some practical takeaways for our listeners. Most of the people listening to this are either developers, product managers, or tech-curious professionals. If they want to start thinking about agentic architecture in this way, where should they begin?
The first step is to stop thinking of your agent's output as a string of text and start thinking of it as a state machine. Even if you aren't using a visualization tool yet, start mapping out the decision tree of your agent. What are the forks in the road? What are the potential loops? If you can't draw a rough sketch of your agent's architecture on a whiteboard, it is probably too complex for you to control. You need to have a mental model of the state transitions before you can expect the agent to follow them.
That is a great rule of thumb. If you can't draw it, you don't own it. It forces you to simplify and clarify your objectives.
Second, I would highly recommend people go to GitHub and look at this Agentic AI architecture visualization project. Even if you don't clone the repo and run it today, look at the way they are conceptualizing these spaces. Look at the diagrams of the circular loops and the latent value maps. It will change the way you write your prompts and design your workflows. You will start to see where you are accidentally creating loops or where you are leaving too much ambiguity in the latent space. It gives you a new vocabulary for describing agent behavior.
And for the developers out there, I would say start logging more than just the final output. Start logging the metadata of the reasoning process. What were the other tools the agent considered? What was the confidence score at each step? You need that data if you ever want to use a visualization tool like this. You can't map what you don't measure. We are moving into an era where the telemetry of the thought process is just as important as the telemetry of the server. You need a full audit trail of the reasoning, not just the result.
Well said. And finally, I think we should all be prepared for the shift from prompt engineering to architecture engineering. The people who are going to succeed in the next few years are not the ones who can write the cleverest sentences to an LLM. They are the ones who can build robust, observable, and efficient agentic structures. They are the ones who can look at a visualization of a latent value space and know exactly which lever to pull to get the system back on track. It is a more rigorous, more engineering-focused approach to AI development.
It is a whole new skill set. It is almost like being a psychiatrist for machines. You are looking at the patterns of thought and identifying the pathologies. Oh look, the agent has developed an obsessive-compulsive loop regarding this specific database query. We need to go in and adjust its latent priorities. You are diagnosing the structural flaws in the agent's reasoning.
Ha! That is not far off, Korn. It really is a form of digital behavioral analysis. And the better our tools are for visualizing that behavior, the more powerful these agents will become. I am really grateful Daniel sent this over. It is a perfect example of the kind of foundational work that is happening right now to make the agentic future actually work in production, rather than just being a cool demo. It moves us from the realm of magic to the realm of engineering.
Definitely. It takes it from a toy to a tool. Before we wrap up, I want to remind everyone that if you are finding these deep dives helpful, please take a moment to leave us a review on your podcast app or on Spotify. It genuinely helps other people find the show, and we love hearing your feedback. You can also find the full archive of all 1066 episodes over at myweirdprompts.com. There is a search bar there, so if you want to find those episodes we mentioned today, like episode 795 or 810, that is the best place to do it.
Yeah, the archive is a goldmine if you are trying to catch up on how we got to this point in 26. And if you have a project or a weird prompt of your own, there is a contact form on the website. We are always looking for new things to explore, and as you can tell, we love getting into the technical weeds. We want to see the projects that are pushing the boundaries of what these agents can do.
We really do. This has been a fascinating one. The idea that we can start to see the shape of an agent's thoughts is just mind-blowing. It makes me wonder what the next step is. If we can see the latent value space, can we eventually merge multiple spaces? Can we take the gut feeling of one agent and transplant it into another? Can we create a library of pre-validated latent value spaces for different tasks?
That is a whole other episode, Corn. But the short answer is probably yes. Once you have the map, you can start doing some very interesting things with the territory. You can start modularizing the reasoning process itself.
I'm already looking forward to that discussion. All right, I think that is a good place to leave it for today. Thanks for the deep dive, Herman, and thanks to Daniel for the prompt. It is always a pleasure to see what our housemate is cooking up in his corner of the house. He is always at the bleeding edge of these observability tools.
It keeps us on our toes.
Thanks for listening to My Weird Prompts. We will be back soon with another deep dive into the strange and wonderful world of human-AI collaboration.
Until next time, keep exploring those latent spaces.
Take care, everyone.
See ya.
One more thing before we go, Herman. I was just thinking about the practical application for a regular person, not a developer, but someone just using these agents in their daily life. Do you think they will ever see these visualizations? Or will this always be a behind-the-scenes tool for the engineers?
That is a great question. I think we will see a consumer-facing version of this. Think about the progress bar we have now for downloads. In the future, when you ask an agent to plan a 3-week vacation to Japan, you might see a simplified version of this graph. It could show you the different options it is exploring and where it is spending its time. It would give the user a sense of progress and also a way to intervene. You could see it looping on flight options and say, hey, stop looking at flights. I have already booked those. Focus on the hotels. It makes the AI's work visible and tangible.
So it becomes a collaborative interface, not just a black box that spits out a PDF, but a transparent process you can participate in. It changes the relationship from user and tool to partners in a process.
Transparency builds trust. And in the world of autonomous agents, trust is the most valuable currency we have. If I can see how my agent is thinking, I am much more likely to trust its final recommendation. I can see that it did the work, that it considered the alternatives, and that it stayed within the bounds I set for it.
I think that is a perfect note to end on. Transparency is the foundation of trust in the age of AI. All right, for real this time, thanks for listening.
Bye, everyone.
This has been My Weird Prompts. Check us out at myweirdprompts.com and on Spotify. We will talk to you in the next one.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts.